Welcome back, Codebreakers. Today we are ending the confusion in AI video. This is not a 5-minute tutorial, this is a full deep dive AI video masterclass. I'm not rushing this, I'm building this video in 3 parts, packed with value from start to finish. Here is the promise. This is the only video you will need to master the entire state of the art in AI video generation. First, for the newcomers. I know a lot of you are new to the channel, so we're going to build a solid foundation. My co-host Astra is going to give us a full AI Frontline report. She'll cover the entire Wan 2.2 ecosystem, what it is, the GGUF models for the low VRAM users, and the open source debate. Second, for the intermediate and advanced users, this is the main event. We are going to do a massive deep dive on stable video infinity. Astra will explain the different confusing models, shot, film, and dance, and then I will take over. I will walk you through my entire pro workflow for SVI step by step. And for the pro users, I will show you the one critical, non-obvious secret, the page file fix that makes infinite video actually work and stops the crashes. That is the Codebreakers nugget you will not find anywhere else. And finally, you're going to want to stick around to the very end. I'm going to be revealing my new personal AI music project, Bengal Nights, and I'll be teasing the next video where I'll break down those insane ComfyUI workflows. It's a huge show, it's polished, and it's packed. Let's begin. Astra, let's start with that AI Frontline report for the newcomers. What is the Wan 2.2 ecosystem?
Thanks, Manny. It's great to be here. Let's get right to it. Our lead story is the one everyone is searching for, Wan 2.2. This is a new open-source family of video models from Alibaba's AI Labs. And the key detail, Manny, is the license, a full Apache 2.0 license, making it free for commercial use. The why comes down to 2 key innovations. First, its architecture. It uses a mixture of experts, or MOE. Think of it as 2 specialists. The high-noise expert acts as the director of photography, planning the overall composition and motion. Then, it hands off to the low-noise expert, which is the detail artist that refines textures and lighting. Second, its training data. It was trained on curated aesthetic data, which is what enables its main feature, cinematic-level prompting.
And that is the magic bit, cinematic level prompting. It means we're no longer just saying a man walking, we're now saying a handheld tracking shot of a man walking with warm backlight and shallow focus. It literally understands the language of filmmaking. And Astra, what about the specs? Can we actually run this thing?
That's the critical question, Manny. And the answer is a definitive yes for most of the Codebreakers community, because the Wan 2.2 family is highly scalable. 5 billion parameter 5B model, which produces that fantastic 720p output, is not limited to high-end cards. Community, through heavy quantization, has made that possible. This is where models using formats like GGUF or FP8 come in. Let's quickly define that. GGUF is a file format designed to make large models, like Wan 2.2, run efficiently by using less VRAM and system memory. It quantizes the model, which is a smart way of reducing its file size and complexity without a major loss in quality. This is what brings these powerful tools to the 8GB and 12GB cards. You can find these quantized models from community leaders like QuantStack on Hugging Face. But there is a critical detail, and this is important for new users. GGUF models do not work with standard loaders. They require their own specific GGUF loader nodes in ComfyUI. You will need to install these custom nodes to get them to work. With those nodes, the 5B model runs very well on GPUs with as little as 8 to 12 gigabytes of VRAM. And even the larger model is being quantized, making it accessible on 15GB cards. The full 14 billion parameter 14B model is completely unlocked. Wan 2.2 gives us incredible quality and cinematic control for short clips. But as you said, this is just the backstory. It solves the quality problem. Now, we must solve the length problem. And for that, we need to look at our next model.
And that's the big challenge, right? Solving the length problem. But before we can even think about solving infinite length, we first need to master the quality problem. And that means we have to do a full deep dive into the entire ecosystem we'll be using. starting with the current king of quality, Wan 2.2. This isn't just one model. It's a whole universe of files from Hugging Face. Different GGUF versions from low VRAM and specific VAEs. It's a lot for a newcomer. So to get us all on the same page, I'm bringing Astra in again. She's going to give us the complete AI Frontline report on the entire Wan 2.2 model space and the exact specs you need to run it. Astra, what's the full report?
Thank you, Manny. Let's begin with the big picture. To understand this ecosystem, you must first understand Hugging Face. Think of Hugging Face as the GitHub for AI. It's a massive open-source library where researchers, companies like Alibaba, and individual developers all share their models, datasets, and code. This model space is a decentralized, collaborative environment. It's the reason we, in the ComfyUI community, can get our hands on state-of-the-art technology almost as soon as it's announced. Which brings us to our primary topic, Wan 2.2. Wan 2.2 is the successor to the already powerful Wan 2.1. As Manny mentioned, its key innovation is the mixture of experts architecture. It splits the job of video creation between two specialists, a high-noise expert that plans the overall scene and motion, and a low-noise expert that fills in the fine details and textures. This new architecture, combined with a much larger, cinematically labeled dataset, is what gives Wan 2.2 its incredible control over camera movement and lighting. Now, how do we get this into ComfyUI? This is where the community and those links become crucial. First, we have the official comfy.org Wan 2.2 repackaged repository. I recommend most users start here. Repackaged is the key word. The ComfyUI team has taken all the essential components, models, the VAE, the clip encoders, and bundled them into one clean, compatible package. It is the all-in-one solution designed to work natively with ComfyUI and minimize installation headaches. Second, you'll see modular repositories like Kijai Wan Video Comfy. This is a custom node implementation. It's lightweight and often updated with new features or performance tweaks, but it assumes you will gather the other necessary files yourself. It's a great option for more advanced users who want to mix and match components. Both are valid, but that Comfy.org repack is your most reliable starting point. So, what are these components? A model like Wan 2.2 doesn't work alone. It relies on a team of other models. First is the clip model. Think of clip as the universal translator. It's what takes your text prompt, like a man walking in a neon-lit alley, and translates that idea into a mathematical language, or embedding that the video model can actually understand. Second is the VAE, or Variational Autoencoder. This is the pixel compressor. Video models are massive, and working with raw pixels is inefficient. The VAE compresses a full-resolution image down into a small, compressed latent space file. The video model does all its work in this efficient latent space, and when it's finished, the VAE decompresses that result back into the video we can see. A good VAE is critical for avoiding foggy or desaturated-looking videos. And finally, ControlNets. These are guidance models. A ControlNet doesn't create video, it forces the main model to follow a specific rule. For Wan 2.2, you have control nets for things like depth or canny edge, which allow you to precisely lock down the camera's motion or the shape of a subject, giving you true directorial control. This entire system is an evolution. Before 2.2, we had Wan 2.1. It was a breakthrough, but it was more complex. It often relied on a separate, specialized component called VACE, the Video Aware Compression Encoder. VACE was a powerful model for unified video tasks, but it was another complex part to install and manage. Key innovation of Wan 2.2 is that it integrates this high-efficiency compression directly into the main model's new architecture. It simplifies the workflow and improves performance, which is why it's replacing Wan 2.1 so quickly. So, Wan 2.2 gives us incredible quality and cinematic control for short clips. But what if you want that clip to last forever? Brings us to our final exhibit, Stable Video Infinity. This is a brand new model from a different research lab, and it has one brilliant purpose: to generate infinite-length video. It doesn't suffer from drift where the video forgets what it's doing after a few seconds. It uses a clever trick called error recycling. It generates a few frames, pauses, and looks at its own output. It actively identifies its own errors or inconsistencies and feeds those errors back into itself as a correction for the next batch of frames. It is constantly self-correcting, allowing it to maintain perfect consistency for minutes at a time. This creates a powerful new workflow. You can use Wan 2.2 to create a high-quality, 5-second cinematic shot and then feed that shot into Stable Video Infinity to extend it into a 1-minute, seamless, looping video. And that is the current state of the video model space. It's a modular, rapidly evolving ecosystem of specialized tools. Back to you, Manny, to show us how to actually connect all these pieces together.
Okay, thanks Astra. That's good, but here's the kicker. Stable Video Infinity runs on the Wan 2.1 ecosystem and not the Wan 2.2. So before we build anything, we have to understand the tools. Astra, take us back in, give us a concise pro-level breakdown. What are these different SVI models and what are their specific requirements?
Thank you, Manny. Let's move to our advanced topic, Stable Video Infinity. This is where most users get confused, so I will be precise. SVI is not a base model. It is a family of specialist LoRAs. These LoRAs are distilled from the main SVI models and are designed to run on top of the Wan 2.1 architecture. The best versions for ComfyUI are from the GGUF Hugging Face repository. The specific LoRA you choose dictates the workflow you must build. Let's look at the main types. The SVI-Shot LoRA. This is for a single, continuous scene that does not change and is an image-to-video workflow. Prompting is the key. You must provide one initial reference image and one single, highly detailed text prompt. To get dynamic motion, your prompt must be like a short story, detailing at least 3 consecutive actions. The SVI-Film LoRA, this is for multi-scene storytelling, with cuts and new locations. It is a text-to-video loop. This is where travel prompts are required. You must write a dedicated prompt for every distinct scene, with each new prompt line creating the next clip in the loop. The SVI-Dance LoRA. This is a specialist tool for consistent, character-locked motion and is a video-to-video loop. This LoRA is designed to be paired with a ControlNet. The prompt is the driving video itself, which the LoRA locks onto, ensuring the character and background remain stable. Workflow Manny is building today is the dance workflow. The other tutorials you may have seen are likely using the SVI-Shot workflow. Understanding this distinction is the key to mastering SVI. Manny, back to you to build the advanced dance workflow.
That's great. Thank you, Astra. So, as Astra mentioned, go to GGUF's repository and grab these models. Place them in your LoRa's folder, then grab the workflow from either my Patreon or you can grab it from my website, codebreakers.site. You could also check out the SVI GitHub page and there is a workflow there. But that is a shot workflow. It's a cinematic workflow and is used with the shot LoRa. I will be adapting that and putting it on my website. Keep an eye out for that over the next few days. Right, so just as Astra said, SVI is not a base model. It's a family of specialist LoRas and they are all designed to run on top of the Wan 2.1 architecture. Now, you're going to find these in the GGUF One Video Comfy repository on Hugging Face. When you look in the LoRa's Stable Video Infinity folder, you'll see a lot of them. It's confusing. Let's break down the main ones so you know exactly which tool to use for which job. First, you have the SVI-Shot. Think of this as the single scene tool. Its job is to take one starting image and one detailed text prompt and create a single continuous long video. It's perfect for landscape or slow tracking shots, where the scene doesn't really change. Next you have SVI-Film. Think of this as the storytelling tool. Its job is to create multiple different shots in a sequence. This is the one you use with travel prompts, where each new line of your prompt creates a new scene. You will also see SVI-Film Transition. This is just a variant of the SVI-Film that's trained to create more dynamic camera cuts and new angles between your prompts. There are also opt versions, which are just optimized or fine-tuned versions. You can test these out. I won't be testing those here today, but feel free to have a go. And finally, this is the one we're using today, the SVI-Dance. Think of this as the ControlNet tool. Its job is to lock into a driving video. It's designed specifically to be paired with a ControlNet like DW Pose. You need to feed it a video of someone dancing, and this LoRa ensures that your character and the background stay 100% consistent for the entire performance, which as I discovered can be thousands of frames long. So to recap, SVI-Shot is for image to video, SVI-Film is for text to video, and SVI-Dance is for video to video. For this masterclass, we're building the most powerful and advanced one, the SVI-Dance workflow. So once you drag and drop the workflow onto the canvas, you should be met with something like this. If there are any red custom nodes, it means you are missing some custom nodes. Go into the manager and install missing custom nodes. Restart ComfyUI and refresh your browser and you should be good to go. As Astra mentioned, if you are using GGUF models, then you do need to use the GGUF loaders, so you need to adapt the workflow for that. Also, make sure all your models are selected in your model loaders and you should be ready to generate. So as complicated as this looks, this is actually quite a simple workflow. There's not much to do with the prompting. You load in a dance video, you load in an image, set your resolution. I find 720 by 1280p gives you a 16:9 ratio. You can flip that for portrait or a landscape. You may have some VRAM constraints, which means you may not be able to generate at this resolution. So just tune down your resolution until it fits inside your VRAM. It is a high demanding workflow, so expect it to pull a lot of system resources. I wouldn't be running anything else while I'm running this workflow, and that's what I've been doing. And the generations have been taking quite long. And press run. So just a few pointers. You do need to have a video and an image that kind of correspond with each other. The model is going to try to reenact whatever's happening in your video. So if your video is of somebody dancing on a dance floor and your image shows somebody standing at the edge of a cliff, then guess what? Now they're not going to drop off the cliff, but they'll probably end up dancing in the sky. So I suggest you take your images and make sure they're just right for your control video. You can use Qwen Image Edit or Nano Banana for this. So I'm going to show you what I was able to generate with this. One thing to realize is that these generations do take a long time. I've had upwards of 30 minutes and 40 minutes on a 5090 to try to generate some of these 1 minute long videos. So just be prepared for long generation times. So as you're watching these vendors, you'll notice the motion is locked perfectly. The SVI-Dance LoRA is doing its job. But you'll also notice the character's face. It's a bit off. It's not a 100% perfect lock. So this is the real secret of mastering this workflow. It's not just plug and play. You are balancing a conflict. If you look at our workflow, we're feeding the model two main inputs, a reference image and a control video. If your reference image is a character just standing there, but your driving video starts with a dancer in a low crouch or something, the model gets confused. It doesn't know how to map the face. This is where you get characters floating in midair or, as I've seen, dancing inside of a wall. So here's a tip. Your assets must be in harmony. The key is making your reference image match the first frame of your control video as closely as possible. So what I do is take my first frame into Qwen or Nano Banana and make sure it works with the driving video. When your reference image and your driving video start from the same place, that gives you a rock solid start. It's all about asset preparation. So once you've prepped your assets, you've set your loop, you're ready to render your first truly long video and hit Q prompt. And then it's going to crash. Now let me show you why, and let me show you the one critical non-obvious fix that makes all this actually work. Okay, now for the final most important part. This is the advanced nugget I promised you. So we've got the workflow and we've set the loop to 800 frames and we hit Q prompt and 10 minutes later, bam, it crashes. Now I've had this a few times. You're going to see a torch out of memory error and you're going to blame your VRAM. You'll think my 5090 or my 4090 couldn't handle it. That is the wrong error. You have to be a codebreaker. So if you scroll up to your console, you'll find the real culprit. The OSError, the win error 1455 is a paging error. This has nothing to do with your VRAM. This is a system RAM problem. This workflow has a RAM snowball. It's accumulating all 800 frames in your system RAM, not your VRAM. When your physical RAM is full, Windows tries to use your C drive as a virtual memory or a page file, but the default page file is tiny. The workflow asks for 150 gigs. Windows has only 100 and it kills your render. Here is the fix, and this is the key to the whole video. Go to your advanced system settings and find performance, then settings, then find the advanced tab and click change under the virtual memory. Uncheck the automatically manage. Select your C drive and click custom size and set the initial and maximum size to a massive number. I set mine to 200,000 megabytes, which is 200 gigs of virtual RAM. Click set, then click OK and restart your PC. And just like that, you've solved it. You can now run that 800 frame render and it will now complete. And that's how you truly unlock stable video infinity, and you're able to do 1000 frame renders. So that is the masterclass. We've covered the Wan 2.2 ecosystem, we've dived deep into the entire SVI LoRA family, and we've solved the infinite length crash that stops 99% of people from creating long generations. Now you're probably asking, Manny, why are you spending weeks crashing your system and trying to generate 800 frame dance videos? Well, all this testing wasn't just for this tutorial. For the last 6 weeks, I've been pouring all this knowledge into a new personal fun project, my new music channel, Bengal Nights. It started as a personal testing arena for these exact SVI and Wan 2.2 workflows, and it's just taken off. In just 6 weeks, we've hit 12 videos and 600 subscribers. So the reason I'm showing you this, the reason it's relevant to Codebreakers, is that every single shot you saw was made 100% in ComfyUI. If you're interested in AI-driven music and art, go check it out. So I'll be making a video soon revealing how I go about making these music videos. Make sure you subscribe to the channel because you don't want to miss that. I hope this has been interesting, and I shall see you in the next one.
সুতায় মন বাঁধে আলগা থাইকা টানে বন্ধু মায়ার জাদু জানে আমার পরাণ ধইরা টানে পিরিতেরি বান মারিলো চাইয়ার নয়নে তোমায় বুঝাই গো কেমনে তোমার মায়া আমায় টানে দুই নয়নে আছে জাদু বলে মনে প্রাণে বন্ধুর মুখে সুখের ছায়া দেখলে তারে লাগে মায়া হাসি মুখে কইলে কথা শান্তি লাগে মনে
তোমার ছবি ভাসে চোখে রাত্র নিশি দিনে তুমি বন্ধু থাইকো পাশে জীবনে মরণে
বন্ধুর মুখে সুখের ছায়া দেখলে তারে লাগে মায়া হাসি মুখে কইলে কথা শান্তি লাগে মনে
তোমার ছবি ভাসে চোখে রাত্র নিশি দিনে তুমি বন্ধু থাইকো পাশে জীবনে মরণে
এত মায়া লাগে কেন চাইলে তোমার পানে এত মায়া লাগে কেন চাইলে তোমার পানে মনের সুতায় মন বাঁধে আর আলগা থাইকা টানে বন্ধু মায়ার জাদু জানে আমার পরাণ ধইরা টানে পিরিতেরি বান মারিলো চাইয়ার নয়নে তোমায় বুঝাই গো কেমনে তোমার মায়া আমায় টানে দুই নয়নে আছে জাদু বলে মনে প্রাণে
বন্ধু মায়ার জাদু জানে
আমার পরাণ ধইরা টানে
পিরিতেরি বান মারিলো চাইয়ার নয়নে
তোমায় বুঝাই গো কেমনে
তোমার মায়া আমায় টানে
দুই নয়নে আছে জাদু বলে মনে প্রাণে